In the last few years, we've all seen this massive, almost unbelievable leap in AI capabilities, right? We've built this incredibly powerful engine, but here's the thing. An engine by itself doesn't really get you anywhere. The real challenge, and what we're going to dive into today, is how we build the actual car around it.
In this quote from Marco Argenti over at Goldman Sachs just nails it. When he says engine, he's talking about those powerful large language models we've all been playing with. But the car, well, that's the AI agent. So the big question is, how do we take all that raw horsepower from the engine and build a car, an agent, that can actually do things in the world, safely and reliably?
So, how do we do it? Well, the answer is something called Agentic Design Patterns. The best way to think about these is like the architectural blueprints for building that car. They're the proven, reusable strategies that let us build AI systems that are smart, robust, and genuinely useful. Okay, so here's our game plan. We're going to start with what an agent is even for, its core mission. Then we'll pop the hood and look at its cognitive architecture, how it thinks. We'll cover how we build in trust and control, which is crucial. Then we'll map out the different levels of agency. And finally, we'll look ahead to a wild idea, a potential agent economy. Let's get into it.
So, first things first, what's an AI agent really trying to do? What's its fundamental purpose? Well, it all boils down to one thing: turning what we want into something that actually happens.
And this right here is the North Star, the goal for any AI agent or AI host. See, it's not just a mindless command executor. It's meant to be a thinking partner. Its job is to take our often messy, vague human ideas, ask questions to figure out the real goal, and only then translate that fuzzy intent into action that's safe, explainable, and reliable.
The technical term for this is an agentic system, and the keyword here is autonomously. Unlike a normal computer program that just follows a rigid script, an agent can perceive its environment, look at a website or a database, make a decision about what to do next, and then act on its own to reach its goal. And this whole process runs on a pretty simple 5-step loop. First, it gets its mission. Then it scans the scene for context. It thinks through a plan, takes an action, and, this is the most important part, it learns from the result to get better next time. This continuous cycle is the basic heartbeat of every single AI agent.
All right, so now that we know the basic loop, let's explore how an agent actually thinks. This is its cognitive architecture, and it's where we get into these really cool patterns for planning, orchestrating tasks, and even collaborating. The first and maybe most important pattern is planning. It's the ability to take a huge goal, like plan a team offsite, and break it down into a series of smaller, doable steps. But a great agent does one more thing. It explains the plan to you before it does anything. It says, hey, here's the plan I'm going to follow. Does this look right? That transparency is absolutely vital for building trust.
And if we zoom in, we see this constant, micro-level rhythm. It's a continuous loop. A thought leads to an action, and the result of that action, the observation, feeds right back into the next thought. This thought-action-observation cycle is how an agent adapts on the fly and course corrects when things don't go as planned.
Now, a single agent can't be an expert in everything, right? And that's where multi-agent collaboration comes in. Instead of building one giant do-it-all agent, you build a team of specialists. One might be a writer, another a coder, another a data analyst. The host agent acts as the project manager, deciding who does what to get the job done.
And this diagram shows you exactly how that works. You've got a supervisor agent at the top that understands the big picture. It breaks the mission down and hands off the smaller tasks to the specialist agents. They do their part and report back. It's basically an org chart, but for AIs, and it's how you get a high-functioning team.
Of course, agents can't just operate in a bubble, and that's where tool use comes in. This pattern is what connects the agent to the real world. It lets the agent go beyond its internal knowledge to do things like search the web for real-time info, pull data from a company database, or connect to pretty much any external service through an API. This is what makes an agent truly practical.
And this slide gives you a little taste of an agent's toolkit. It can grab a web browser, query a database, or even call another agent to act as a tool. This ability to reach out and interact with the digital world is what turns a simple plan into a complex, powerful action. Okay, so this is a really important section. With all this power to act autonomously, how do we make sure these agents are safe, predictable, and worthy of our trust? This is where the patterns for correction, control, and communication become absolutely critical. This right here is the guiding philosophy. We have to accept that agents will make mistakes. It's inevitable with complex tasks. But as it says here, uncorrected mistakes are unacceptable. A well-designed agent has to be able to spot its own errors and, more importantly, fix them.
The reflection pattern is how we achieve that self-correction. It's a really smart three-step loop. First, the agent executes a task, then it actually stops and critiques its own work. Finally, based on that critique, it refines its output. It's this iterative feedback process that really pushes the quality of the final result way up.
Another huge piece of the trust puzzle is risk awareness. A truly intelligent agent knows when not to act. Just like this quote says, it needs to be able to identify high-risk actions, things like deleting a file or spending money, and pause to ask for human confirmation. These guardrails are absolutely essential for using agents in the real world.
All right, let's pull all these ideas together now. Agency isn't just some on or off switch. It's really an evolutionary path. We can actually think about it in 4 distinct levels, with each one getting more and more sophisticated.
In this pyramid is a great way to visualize that journey. We start at the very bottom with the core engine. From there, we add tools, then we add strategic planning, and finally we reach the top with these complex, collaborative, multi-agent systems. Each level literally builds on the one below it.
So let's break that down real quick. Level 0 is just the raw LLM, the brain. At level 1, we connect that brain to tools like a web search. At level 2, the agent gets smarter, adding proactive planning. And finally, at level 3, you get the whole shebang, collaborative teams of agents working together to solve really tough problems.
So where is all this technology headed? Let's zoom way out for a second and think about the potential long-term impact this could have on our entire economy.
This is the really mind-bending question we need to start thinking about. What happens when these systems stop being just tools that we use and instead become autonomous economic actors in their own right?
The future could very well be an agent economy. Just imagine autonomous agents running entire businesses, managing marketing, logistics, customer service, all of it. This could create a totally new, hyper-efficient market that operates at machine speed. So the challenge ahead isn't just about building a better engine, but about thoughtfully designing the intelligent cars that are going to shape the world we live in.